Okay, law of sines. Before we actually talk about the law of sines, I'm going to show you all how to get the area of a triangle using trigonometry. So let's say that I draw the height right here. I'm going to label this triangle A, B, C. Now it's common convention to label the angles with capital letters and the sides with lowercase letters. And lowercase side A will always be opposite angle A. Side B will always be opposite angle B. And side C will always be opposite angle C. So if I call that H1, then you see I've made a right triangle right here. So I can say that the sine of angle C is equal to H1 over B, or B sine C is equal to H1. That means that the area of this triangle is 1/2 the base, well, the base is side A, times the height, which is B sine C. Okay, so what would happen if I took this triangle and I rotated it around and changed it so that now that's A, I believe that's B, that's C, which makes this angle A, angle B, angle C. And instead of drawing my altitude from angle A, let's draw it from angle C. We'll call that H2. Well, once again, the sine of angle B this time is now H2 over A. So that means that A sine B is this height. And so our area is 1/2 this base times the height. Now I could do it a third time with angle C, but y'all get the point. So what happens is we have three ways of expressing the area. I can do AC sine B over 2, or I can do AB sine C over 2, or I can do BC sine A over 2. They're all the same triangle, so they're all equal to each other. What would happen if I took this three-sided equation and multiplied everything by 2 and divided everything by A, B, C? Have to write really small here. There we go. Well, if I distribute that, then AC cancels here and the 2's cancel there, and I get that the sine of angle B over side B is equal to, and here AB will cancel and that 2 will cancel, the sine of angle C over side C. And then here BC's will cancel along with the 2's, and I'll get the sine of angle A over side A. And that is a very elegant and nice formula called the law of sines. And the advantage of this law is that it works for any triangle, not just right triangles, but any triangle. Let's do an example. So let's say that angle A here is 100 degrees. Side A is 125. Side C is 10. So we'll make that angle C. And there's angle B in side B. So it's our job to find the missing parts of this triangle. Well, I can say that the sine of 100 over 125 is equal to the sine of angle C over 10. So 10 sine 100 over 125 is the sine of C. Now remember, I'm looking for an angle, so I'm going to need to use inverse trig right here. So let's bring in our calculator, turn it on, and I want to make sure that I'm in degree mode. And now I am. And I just go 10 sine 100, close parentheses, divided by 125. And that equals, let's see, what was that? 0.7878. Point 7878. Oh, 0.078, I was right. Equals the sine of C. So now I take the inverse sine of my answer, and angle C is 4.52 degrees. So to get angle B, I'm just going to subtract 180 minus 4.52 minus 100. $75.48. Now let's erase that little dot there. So now that I know what angle B is, I can get side B. The sine of 75.48 over B is equal to the sine of 100 over 125, which means that B is 125 sine 75.48 over the sine of 100. And let's work that out. 125 times the sine 75.48 divided by the sine of 100, 122.9. So we've gotten all the missing pieces, all three angles and all three sides. Something you have to be careful about when you're using law of sines, though, is a thing called the ambiguous case. And basically, if you're given side A, side B, and angle A is acute, and side A is less than angle B, then there are two possible triangles that can be constructed with the given information. For example, let's say that angle A is 30, side A is 7, and side B is 10. Alright, so I can say that the sine of 30 over 7 is equal to the sine, we'll make this angle B, angle C, sine of B over 10. So 10 sine 30 over 7 is sine B. Let's calculate that. Here, let's clear out all this stuff. Alright, 10 sine 30 divided by 7 Then I'm going to take the inverse sine of that. And I get 45.58. Well, okay, so that's if angle B is acute. But angle B could also be obtuse because sine is positive in both the first and second quadrants. And so to cover all our bases, we have to say that B could equal 45.58 degrees or 180 minus 45.58 degrees, which is equal to 180 minus our answer, 134.4. So which one's right? Well, they're both right, and you have to construct two separate triangles. One with B as a 45-degree angle, and another one with angle B as a 134-degree angle. This triangle here will have an obtuse angle at C, and this triangle here will have an acute angle at C. And so you just construct two complete triangles using those two values for B. That's pretty much what you need to know for law of sines. Good luck on your problems.